Hi, welcome to Engage New York, Lesson 16. This is Module 4. This is the problem set this is the problem set, which is what we normally go to after we've done concept development. But today we're going to work through these problems together. And then what we're actually going to do, we're going to do a couple of problems together. I'm going to set you free to have you do a couple of problems and then come back and check your work to see how you're coming along on developing this idea. So today's lesson involves learning a new type of tape diagram, but there are multiple approaches to solving this problem. So if you have a mathematically sound procedure for solving, that is perfectly okay. But our goal here during this concept development / problem set is to use a new type of tape diagram in order to solve these problems. So we're not actually going to start with problem 1 right now. We're going to start with problem 2. So Joaquin is icing 30 cupcakes. He spreads mint icing on 1/5 of the cupcakes. Okay, so 1/5 of the cupcakes and chocolate on half of the remaining cupcakes. So half of the remaining cupcakes. The rest will get vanilla frosting. How many cupcakes have vanilla frosting? So we're going to use a tape diagram to solve this problem. This problem is about Joaquin's cupcakes. What does the first sentence tell us? Well, Joaquin has 30 cupcakes, right? So Joaquin is icing the cupcakes. What fraction of the cupcakes receives mint icing? You're right, 1/5 of the cupcakes. So here we go. Let's start by drawing this out. So we're going to draw a tape diagram, but what should we draw? So Joaquin is icing 30 cupcakes. He spreads mint icing on 1/5 of the cupcakes. What should I draw? Well, hopefully you're saying you should draw a tape diagram and divide it into 5 equal pieces. 1, 2, 3, 4, 5, right? All right. Now, he spreads mint icing on 1/5 of the cupcakes. So what should I label right now? Okay, so 1/5 has mint icing on it, right? And what does this tape diagram, how much does it represent? It represents 30 cupcakes, right? How are you doing? So we partition the whole into 5 equal parts, 5 equal units, and then how many units had mint icing? Well, 1 unit had mint icing, right? Okay, so let's read the next sentence. And okay, so he spreads mint icing on 1/5 of the cupcakes and chocolate on half of the remaining cupcakes. So where are the remaining cupcakes in our tape diagram? Well, the remaining cupcakes on our diagram are the unlabeled part, right? So this is how I told you I'm showing you how to do a new type of tape diagram. So what else do we know? The rest, and chocolate on half of the remaining. How many are remaining? 1, 2, 3, 4 units, right, are remaining, and half of the remaining cupcakes get chocolate icing. correct? All right. How can we represent that in our new tape diagram? Well, let's pull this diagram down. And here is our 4 units, correct? So we're going to cut it. We're going to cut it. Here is 1, 2, 3, 4. So 1, 2, 3, 4 cut. If we cut 4 in half, there would be 2 and 2, right? All right. So what about the rest of the cupcakes? Well, we know half of the remaining cupcakes get chocolate. So half get chocolate icing, and then the rest are vanilla, right? But what are we trying to solve? How many cupcakes have vanilla icing? We want to know how many, right? All right, so that's our big question, right? This half, how many of those cupcakes? How many are vanilla? So let's look at our tape diagram to see if we can find how many cupcakes get vanilla ice cream. How many units does the model show? Altogether, how many units does the model show? It's 1, 2, 3, 4, 5 units, right? And 5 units is equal to 30 cupcakes. Oh, we've done something like that before, haven't we? We've done 5 units is equal to 30 cupcakes, right? All right, so if I want to find out how much 1 unit is worth, I'm going to divide by 5 and divide by 5. That cross cancels and becomes 1 unit is equal 30 divided by 5 is equal to 6, right? So each unit has 6 cupcakes in it. All right, so if 5 units equals 30 cupcakes and I want to find 1 unit, then I do my 5 units is equal to 30. And we know that 5, if you divide each side by 5, I'm going to bring this down. This cross cancels and it becomes 1 unit. Then I'm able to find out how much 1 unit is equal to. So 1 unit is equal to 6 cupcakes. So that means there's 6 here, 6 here, 6 here, 6 here, and 6 here, right? So down here, if we brought, now we're going back here. So we have 6, 6, 6, 6, right? So we just go ahead and label that on your tape diagram. So now, how many cupcakes are right here? Well, 6 times 4 is 24. And we remember it was half, so 24 divided by 2 is 12. And even just filling this in, you can tell that there were 12 chocolate cupcakes, and now we have how many vanilla? 12 vanilla cupcakes. All right. So the answer to our problem is there are 12 cupcakes with vanilla icing, correct? That's what we were trying to solve. Isn't that right? Okay, so let's think of this in another way. Let's look at this. What fraction? Let's think of this another way. So when we label 1/5 of the mint icing, what fraction of the cupcakes are remaining? So when we label this 1/5, right? 1/5 was mint, what fraction of the cupcakes were remaining? Hopefully you're saying 4/5. So what does Joaquin do with the remaining cupcakes? So 1/2 of the remaining cupcakes get chocolate icing. So I'm going to solve this one more way, where I told you there were different ways to solve these problems. Let's try it this way. So 1/2, we're trying to find what half of 4/5, right? So 1/2 of what fraction? 4/5. So we could solve that quite easily. So I could just cross cancel here and I end up with 2/5, right? Well, 1/2 of 4/5 is 2/5. Well, that makes sense, right? We can see that right here. 1/2 of 4/5 is 2/5. So 2/5 of all the cupcakes got chocolate and 2/5 of all the cupcakes got vanilla. The question asked us how many cupcakes got vanilla icing. So let's find 2/5 of all of the cupcakes. So let's do, what is 2/5? Because that's what we're actually trying to figure out, right? What is 2/5 of 30? That's what we're really trying to solve, isn't it? So 1/5 of 30 is 6. We know that. 1/5 of 30 is 6. So 2/5 of 30, well, we already know it's 12, right? Well, we're going to change this to a multiplication sign. We're going to go ahead and cross cancel. 6 times 2 times 6 is 12 cupcakes have vanilla icing. Right? Okay. So we solved it. Using the fraction multiplication, we got the same answer, 12 cupcakes. Isn't that correct? Yes, it is. All right, so what I'm going to have you do right now, I'm going to grab another, I'm going to go to my page that I wrote this problem out on. Maybe you can write it on another piece of paper as well. I want to try something else. I'm going to do this problem again, but this time let's imagine that Joaquin put mint icing on 2/5 of the cupcakes instead of 1/5. Okay, so let's try this. Okay, so 1, 2, 3, 4. So this time we're trying to find, we know, so this time we're going to say he put mint icing on 2/5. All right, so what fraction of the cupcakes is remaining this time? Well, what's remaining? 3/5 is remaining this time, right? Okay, so let's pull that tape diagram. Let's draw another. Let's transfer this whole tape diagram down here. And let's just work with what is left. Okay, so you want it to match and be the same length. So has the value of 1 unit changed in our model? So have I changed any of the values? No, right? The unit is still 6 because the whole is still 30 cupcakes. The only thing we changed was how many got mint, right? Okay. So we still have fifths. Each unit is still 6 because we still divided 30 into 5 equal parts. So if we went 5 units is equal to 30, and we did our division, right? And we ended up with 1 unit is equal to 6, right? So we still have the same thing. So how many remaining cupcakes are there this time? Well, remember, we didn't change the value. We didn't change the value here. So we have 12 got mint, right? So now we have 6 times 3, right? 6 times 3. What does 6 times 3 give us? Well, it gives us 18 cupcakes altogether, right? And we know that the half of the remaining cupcakes, so half got chocolate and the other half got vanilla, right? So let's imagine that Joaquin still put chocolate icing on half of the remaining cupcakes and the rest are still vanilla. How many cupcakes got vanilla icing this time? So what do you think we should do? So now we're taking this and bringing it down. So we're now going to divide this into half, right? So 18 divided by 2 is 9, isn't it? So we have 9 cupcakes. 9 cupcakes have vanilla icing. So I just wanted you to see this a couple of different ways. All right. So we could just multiply 1/2. So let me show you this here. So 1/2 times 3/5, and you get 3/10, right? So we're trying now, so this is doing this fraction multiplication here. So 3/10 of 30 is going to give us what? 9 cupcakes have the vanilla icing. All right. So we needed the amount, not the fraction. So we needed to multiply 3/10 and 30 to get 9 cupcakes. All right, so what I'm going to have you do now, so you've seen this problem and set it 1/5, and you've seen it with 2/5. You've seen it 2 different ways, and how to take the remaining, and you're trying to find a fraction of what the remaining is. Okay. What I'm going to have you do is I'm going to have you go back to problem 1. And I want you to use the strategies to solve problem 1. So let's look at problem 1. Mrs. Suko made 60 cookies for a bake sale. She sold 2/3 of them. Okay, so she sold 2/3. So what are you going to do with that tape diagram right off the bat? 2/3. And gave 3/4 of the remaining. So now you have to take the remaining and she gave 3 of the fourths of the remaining cookies to the students working at the sale. How many cookies did she have left? All right, go ahead and try this out and come back and check your work. Okay, so let's take a look at how I broke this problem up. I started with drawing my tape diagram. All right, that's what I did first. Then I labeled sold 2/3. I went, okay, she sold 2/3 of it, and then gave the rest and gave 3/4 of the remaining cookies to the students working at the bake sale. So I took this unit right here and I pulled it down. Remember, I didn't have this 20 here yet because I didn't solve that yet. All I know at first is that this tape diagram represents 60 cookies. I know she sold 2/3 of them. And then what was remaining, that's what I pulled down. So from here, I went, well, 3 units is the same as or equal to 60 cookies. That's what we know. 3 units is equal to 60 cookies, right? So I divided what I do on one side, I do on the other. That takes me down to 1 unit. 1 unit equals 20 cookies. I came back up here. I filled in my units from there. After I did that, I went, okay, I know that this is equal to 20 altogether. And I know that it's broken up into 4 equal parts. So I broke it up into 4 equal parts. From there, I said 20 divided by 4 equal parts is going to give me 5. So there are 5 in each unit here. So I want to know, she gave 3/4 of the remaining cookies to the students working. So she gave away 15 cookies. What was left over? 5 cookies. She had 5 cookies left. Okay, another way to solve this. Now, I like to see the problem develop. So this is the way my brain tends to work. But if you jump straight in, what is 1/4 of 1/3? So this is 1/4 right here. 1/4 of 1/3. That's where that came from, right? Because what's left, what is the remaining? That's what you're trying to find. What is remaining? I want to find out what 1/4 of 1/3 is, which is 1/12. So now I have to multiply 1/12 times 60, and you get 5 cookies. All right. Hopefully you might need to erase and rework this problem in order to figure out which way your brain works best, or maybe you got it right away. All right, problem 3. We're going to do the same thing. I'm going to read it to you, walk you through it a little bit, and then let you go ahead and try to solve, and then we're going to come back. And then you'll check your work. Okay, here we go. The Booster Club sells 240 cheeseburgers. Okay, 240 cheeseburgers. So remember, we're drawing our tape diagram, right? And we know the Booster Club sells a total of 240 cheeseburgers, right? Is equal to 240 cheeseburgers, right? Okay. Now, 1/4 of the cheeseburgers had pickles. Half of the remaining burgers had onions, and the rest had tomato. So, how many cheeseburgers had tomato? All right, this is your turn again. I want you to go ahead and use what we've just done in problem 1 and problem 2 to help you solve successfully problem 3. Go ahead and try it and then come right back and check your work. All right, how did you do? Okay, so I started off. I drew out my tape diagram. I know that my tape diagram is equal to 240 cheeseburgers. I know 1/4 of the cheeseburgers had pickles. So I am going to divide this total into 4 equal units. And I know 1 unit, 1 of the 4 has pickles, right? I did not have the 60 units yet, right? So from there, I took what was left over, the remaining burgers, right? And I pulled it down and I created a new tape diagram. And I know 1/2 of the remaining burgers had onions. So I'm going to take what's left over, divide it in half, correct? All right. Now, I know half have onions and the other half have tomato. So what do? I want to find out how many are in each unit. So 4 units, 1, 2, 3, 4, 4 units is equal to 240 cheeseburgers. I'm going to divide, and I get 1 unit is equal to 60. So now I go back up here. I put in my 60 units. Well, how many are in this altogether? Well, 60 times 3 is 180. So I know there are 180 all together here. And it's 180 divided by 2 is 90, because half of the remaining burgers had onions and the rest. So the other half have to have the tomatoes. So 180 divided by 2 is 90. 90 cheeseburgers had tomato. Or you could take 1/2 of 3/4. Here is 1/2 of 3/4 is equal to 3/8. So 3/8 of 240 is 90 cheeseburgers. So both are solid, sound strategies for solving. I know I prefer, my brain works better whenever I get an encounter a word problem. I always draw a picture. So it's mathematically sound, but I feel like I really know where everything is coming from here. All right, next problem. We are going to go to problem 5. So we're going to go to problem 5 from here. All right, are you ready? Let's go ahead and read it. Milan puts 1/4 of her lawn mowing money in savings and uses 1/2 of the remaining money to pay back her sister. So she puts 1/4 of her money in savings and uses half of the remaining money to pay back her sister. If she has $15 left over, how much money did she have at first? Okay, how is this problem different from the ones we've just solved? Because it is a bit different. Why is he calling me?
Your father had only asked her about his favorite?
Sometimes in his car.
Did he carry his car also his rituals?
Possible, I don't know.
Normally he was reaching with by way of his cell phone, huh?
Yes.
And when he finally got home that night, he saw those scratches. Suspicion, according to the prosecution.
Did you ask him about those scratches?
I did.
What did he tell you?
He explained they were from branches from riding his bike.
And then the prosecutor asked Charlotte, and then former boyfriend Jacob, about the weird business of the golf club cover. The golf shop. It appeared that a photo of Steve's garage night of the murder, but was gone when detectives returned with another search warrant. The implication, of course, was that the cover fit the plot never found that killed Charlotte. It had said that after the detective left, he talked to Steve.
What was that conversation?
The golf headstock cover was found after they had left.
He said he had found it.
Yes.
Did he say what he was going to do with it?
He didn't know whether or not to turn it into the police or give it to his lawyer.
Implying to the prosecution that Steve knew the golf shop could incriminate him and didn't know what to do with it. But just as the case seemed to be filled with momentum, 2 weeks into the trial, Judge Thomas Lindbergh left the bench at lunch break and suddenly collapsed. It was a break to murder. And everyone waited for 5 weeks until a brand new judge was appointed so they could pick up the testimony right where they left off. And that's when the jurors finally got to hear what became of the missing golf cover.
Go ahead and open your evidence.
Detective Teresa Kennedy showed it to the jurors, and the judge claimed a stipulation made by the attorney. Even now, days after Carol's murder, Steve gave the golf shop to his attorney, John Sears, who kept it in his locked office until Steve's arrest. That's when Sears turned it over With a curious picture of migrating pub stock in an attempt to cover up a murder, or a bit of confusion, and investigative dead end. Prosecutors weren't done. They next tried to tie Steve to the crime scene. Didn't find any of Steve's DNA or fingerprints at Carol's house, but they did see those tire tracks. The printing was compared to the tires on Steve's bike.
The tread on this tire is similar to the tread you threw this tire truck. And did you find any discernible differences between them? No, I did not.
And those shoe prints, they brought in an expert from the FBI.
Did you find any shoes that seemed to be comparable to the impressions that you observed in these photos from the crime scene? Yes, I found one shoe that could have made those impressions.
A Sportiva Pikes Peak. Records show that Steve bought a pair of those shoes 2 years before the murder. But when detectives searched his house, they didn't find any such shoes. So, intriguing but hardly proof. Prosecutors knew that he had a big problem. That anonymous email linking the murder, not to Steve, but to Jim Knapp and Bill Drugs. So even as the trial went on, investigator Mike Sachet was interviewing and re-interviewing witnesses, including Steve's girlfriend, Renee Gerard.
It was obvious to me that she was very protective of Mr. DeLonghi.
Steve began dating Renee when he was separated from Carol. They were together during that tumultuous time. Steve's divorce, Carol's murder, his arrest. Renee had always stood by Steve and his family. But Sachet had the feeling.
We were pretty convinced that she knew more than she was telling us.
Sachet knew something else too. During the trial, Renee broke up with Steve. So, on the eve of her testimony, Sachet interviewed Renee again about that anonymous email. What he discovered? Explosive is not too big a word. Coming up.
Steve was terrified. He was terrified.
When big one, get big.
Okay. Deshaun is sorting his rock collection. Deshaun is sorting his rock collection. 2/3 are metamorphic. And 3/4 of the remaining and 3/4 are igneous. Okay. If the 3 rocks left over are sedimentary, how many rocks does Sean have? Okay. Okay. 3 3 rocks left over are sedimentary. It's not a question mark. Three. How many rocks does Sean have? So, if 1 unit is equal to 3, then 4 units times 3 equals 12. So 12 times 3 equals 36 rocks. Deshaun has 36 rocks. Okay. One. So 3/4 of 3 3/4 of 3. 3/4 of 1/3. 3/12.
Morning John Cooler in the Arizona mountains. Summer flies from the town square was stored away for another year. And the river pile of steep Walker ticked into its fifth full month. The prosecution had allowed it for circumstantial bits and pieces at the time. And investigator Mike said knew that Steve was likely to not as strong as Steve.
The Walker is a very intelligent individual, but he's also a very narcissistic personality. Put those together, and you can make it difficult to solve the problem.
Narcissistic. That's what it seemed like with the detective. It also seemed to him like Steve's girlfriend, Renee Gerard, was protecting him. Knew more than she was telling him. Then they broke it off. Steve had to protect his one more time. And remember the anonymous two men who claimed Carol's murder was linked to a serious birthday? Oh,
She told me that Mr. Walker had informed them during one of their in-person visits at the jail to bring some pencil and paper. There was a glass between Mr. Walker had brought a document with him that he placed on the glass so that they could view it.
according to Renee, Steve himself wrote that document. Then I thought sharp just like we copy it then.
Mr. Walker then asked them to send that document, which became known as the anonymous email, to Mr. Seward and to the prosecutor's office.
Mr. Sears, or Tom Sears, one of Steve's defense attorneys. Steve's reasoning, according to Steve, the sheriff, he heard that story from an inmate in that airplane conversation, and desperately wanted to get the story out and investigate it.
You left him to himself. So Steve was terrified, we were terrified. I can certainly appreciate it when you're terrified. Maybe you do some stupid things.
Well, things come first, now that and I'm from back off. Then investigators to what they thought was not an even bigger one. Remember Carol's life insurance money? $750,000. These defense attorneys talked about it during the opening statement. This show is not good. And we were known for the that's what happened there. That state felt that was my shit by surprise.
We have been in contact with the life insurance company several times throughout the investigation, and we have been informed that the life insurance had not been paid out to anyone.
So, the insurance came out. What happened? So they took another look. Much harder for the money trade.
Not only was the insurance paid out, it was paid to the two dogs who then transferred it to several accounts, including wire transfers to Mr. Walker's parents' account in New York, and then wire transferred it back to Mr. Walker's defense team.
Under Steve DeMarco was a highly paid financial advisor. The prosecutor now believes he was using that expertise to try to get away with murder.
Here's a person that murdered his ex-wife, then collected her life insurance of over $750,000, and is using that life insurance to pay the defense team in the murder prosecution.
From then, prosecutors established fraud to the charges he was facing. But fraud is certainly not what he thought, said defense investigator Rich Robertson. These girls, all of them, believed in the father's innocence, dedicated to what he did. They deserved
The girls decided to use that money for their dance defense. There was no fraud, or the insurance company